Today we will be learning about correlation, the basics of correlation, scatter plot, and two different type of correlation, that is positive and negative correlation. Now, I hope you all know what is a bivariate distribution. In a bivariate distribution, there will be two variables. Two variables are involved in a bivariate distribution, and yes, we used to find the relationship, or we are interested in finding out the relationship between those two variables. Now, if there are more than two variables, yes, we can also find out, or we can also study the relationship between more than two variables. And for that, we make use of a statistical tool called correlation. So correlation is nothing but a tool, a statistical tool that is used for studying or analyzing the relationship between two or more variables. Correlation studies the relationship. So as I said earlier, the correlation studies the relationship between two or more variables. It involves various techniques used for measuring and studying the extent of the relationship between the variables. Now let's go into a deep look. Now let us consider some examples. The amount spent by advertising and that received by sales is one example that I have to quote, and the other one is the income and expenditure of a family. So here in the first example, the amount spent by advertising or amount spent in advertising for a particular product is your one variable, and the other variable is the sales received by using the advertisement. So we will have, as a business person, that particular person will have to check whether there is any correlation between these two variables for improving his business. The second is income and expenditure of a family that you might have encountered in your day-to-day life. So here also we unknowingly check whether there is any correlation. It is true that we don't use the term correlation as it is in our day-to-day life, but we unknowingly check whether there is any correlation between the two variables, that is income and expenditure. Okay, so I hope you all know that this happens every month, most probably at the end of the month or at the beginning of the month. This is something that is seen in every family. Next is the height and weight of a group of people. So here height is in one variable and weight is another variable, and we check whether there is any correlation between height and weight of a group of variable. Fourth one is the price and demand for a commodity. Here price is one variable and demand is the other variable. And what do? Yes, we study whether there is any relationship between the price and demand for a particular commodity. Further, two variables are said to be correlated if the change in one variable results a corresponding change in the other variable. That is, for example, if we take the fourth example, if there is an increase in price, will there be any change in the demand for that particular commodity? So what do? We check whether there is any correlation between the price. If there is any increase in the price, is there any increase in the demand, or is there any decrease in the demand? So that, how do we check? We use the statistical tool correlation. Now let's move on to the definition of correlation. So here I have given two definitions. You can take any of the two. If two or more quantity vary together such that the movements in one tend to be accompanied by the corresponding movement in the other, then they are said to be correlated. The next definition is, it is very similar, so you can take either the first one or the second one. no issues. If the quantities are so related that the fluctuations in one tend to be accompanied by the corresponding fluctuations in the other, direct or inverse, the two variables are said to be correlated. Okay, so this is the definition or of what we have said in the previous slides. Now there are some types of correlation that you will encounter as you move on. So the first one is positive and negative correlation. Second is linear and non-linear correlation. And third is simple, multiple and partial correlation. So for the time being, we will be dealing with the positive and negative correlation. Positive correlation. If the value of the two variables deviate in the same direction, that is, an increase in the value of one variable result in the corresponding increase in the value of the other, then it is said to be positively correlated. Similarly, if the decrease in the value of one variable leads to the corresponding decrease in the value of the other variable, then the correlation is said to be positive correlation. So then also, there exist two cases. So it is nothing but if the two variables are deviating in the same direction, it might be an increase or it might be a decrease, but if both are moving in the same pace, same direction, then both the variables are said to be positively correlated. Now I will give an example. Now let x and y be our two variables. Now as you can see here, the values of x are 10, 12, 15, 18 and 20. It is a clear increase over here. And let's see what the corresponding y values are: 15, 20, 22, 25 and 37. It's also a clear increase over here. So this indicates that x and y travels in the same direction. So that means both these variables x and y are positively correlated. So I just have given the example for the first case. I haven't given the example for the second case. The second case is somewhat similar to this. The only thing is that when x decreases, the corresponding y will also decrease. So there is a graphical representation of what I have given in the table. So this is the graphical representation. So whenever there is a positive correlation, you can clearly see that there will be an upward trend like this when you plot the values. That is, it is moving in the same direction. Okay. So this we will come to the graphical representation part. We will come to in detail when we talk about the scatter plot. So right now you just have to think that a positive correlation is an ideology where two variables deviate in the same direction, and keep this example in your mind. So next we will move on to the negative correlation. So in a positive correlation, what we talked about was the two variables moving in the same direction. But in negative correlation, it's all about moving in the opposite direction. That is, if you have two variables x and y will be moving in an opposite direction. So let's have a look. If an increase in the value of one variable leads to the corresponding decrease in the value of the other variable, or the decrease in the value of one variable leads to an increase in the value of the other variable, then the correlation is said to be negative. So here also you have two cases. If a value increases and the corresponding other value, that is, if the value of x increases and the corresponding value of y decreases, then that means x and y are negatively correlated. Similarly, if the value of x decreases and the value of corresponding y increases, then that is also called as a negative correlation. So negative correlation in short is nothing but if the variable deviates in opposite direction. Now let's take a look at the table. I have two variables x and y. The values of x is given as 20, 30, 40, 60 and 80, and the corresponding values of y is given as 40, 30, 22, 15 and 10. Here the values of x is clearly increasing, right? So, but what happens to the corresponding values of y? Yes, it is a decrease that we see over here from 40 to 10. It's coming to 10. Here it's 20 to 80. So it is clear that there is a, yeah, both the variables have a tendency of moving towards the opposite direction. Now let's have a look at the graphical representation. As you can see, the graphical representation, it has a downward slope. If you draw a line over here, it has a downward trend. Now this is how a negative correlation looks like. Okay, so again, as I said, I would explain more about this when it comes to the scatter plot part. Now, an important term that you have to always keep in your mind is Karl Pearson's correlation coefficient. So let's have a look at what is Karl Pearson's correlation coefficient. Now, Karl Pearson's correlation coefficient, or it is also termed as product moment correlation coefficient. Now, usually it is represented by small r. Okay, small r, and the formula is given by the covariance of xy divided by standard deviation of x multiplied by standard deviation of y. I hope you all know what is standard deviation of y. Now you won't be familiar with covariance of x and y, but standard deviation of x and standard deviation of y you have studied in my last video. So let's have a look at, now for the time being you keep this aside, the numerator. I will give you another formula where it only involves x values and y values. You can use this formula, or I will give you another formula where it involves the arithmetic mean of what x and arithmetic mean of y. So any of these three formulas, whichever one you use, you will get the answer. It's all up to you. But for the time being, you will be only studying the theoretical part. Okay, there won't be any problems for you as of now. So we will just move on with the theory. Now, after finding R, or after finding correlation coefficient, what is the next step? What is this for? Why should you find out R? So from R, you can make certain interpretations and you can come to a conclusion about the relationship between X and Y. So how do you come to a conclusion about the relationship between X and Y? By calculating R. So that is the next step that we have to do. So there are some interpretations. If you find out R using any of the three formulas, and if you get a value which is in between 0 and 1, then it is said that there exists a positive correlation between X and Y. Right, so that is the first interpretation. And since there exists a positive correlation between X and Y, what does that mean? X and Y deviates or travels in the same direction. Similarly, after finding R, if you get a value which is in between -1 and 0, then it is said that there exists a negative correlation between what? X and Y. And what does that mean? It travels in opposite direction. One more case, if you get, this is also a possibility, if you get R is equal to 0, that means that the variables X and Y are not at all correlated. They are uncorrelated. Okay, so these are the three interpretations that you can make by finding out R. You need not even plot the graph. You can either find the R and come to a conclusion regarding the relationship between X and Y. Now, that is one way of finding the correlation. Now, there are certain properties of correlation coefficient. Now, correlation coefficient is independent of change of origin and change of scale of the measurement of variables. That is the first property. The second property is that the value of R lies between -1 and +1. So if you get anything more than 1, just think that you got a wrong answer or something is wrong with your calculation. Then third is it is independent of the units of measurement of the variables. So these are the three properties of correlation coefficient. Now let's move on to scatter plot. By using a scatter plot also you can find out whether there is any relationship between x and y. So let's have a look at the different scatter plots that we will encounter when we do a problem. Now usually this is how a scatter plot looks like. There will be a lot of points here and there, but it need not be always like this. This is one way of looking at a scatter plot. Now let's see what is a scatter plot. It is a graphical representation of bivariate data. Bivariate data in the sense when two variables are involved. Okay. Now the independent variable. So usually the independent variable is taken along the x-axis and the dependent variable is taken along the y-axis. So usually the independent variable is denoted by x and it is taken along the x-axis, and the dependent variable, which is y, is taken along the x-axis. Now usually we get a pair of observation to plot on the graph. So that is how you plot a scatter plot. Now there are two kinds of scatter plot that we encounter, two or three. I would like to say it as three. So one kind of scatter plot that we might encounter at any point of an analysis is the positive correlation, is the representation of positive correlation. So here in this scatter diagram, if the points cluster around this positive slope, this line is called as positive slope. If it cluster around, or if it is around these line, then it is said that x and y are positively correlated, and it has an upward trend also, as you can see. And in this case you can clearly say that r is where it is between 0 and 1, since it has a positive correlation that we have studied earlier. Also the points plotted fall exactly. That is, if the points, so in this case here the points are not exactly falling on this positive slope. Only 1, 2, 3, maximum 4 points are falling on the slope. But if the points exactly fall on this upward slope or positive slope, then it is said that there exists a perfect positive correlation. So in this case I can't say that it is a perfectly positively correlated random variable, no, because there are values over here, it's not lying on this line. So if you encounter a case when the points lie on this pink line, then it is said that we have a perfect positive correlation. Now we'll move on to the negative correlation. So negative correlation, when you plot a graph, you will get a downward trend like this. And again, as you guessed, this is the negative slope. So when the points cluster around this pink line or the negative slope in this manner, then it is said that x and y are negatively correlated. So here again it is clear that since it is negatively correlated, your r lies between -1 and 0. And again, if the points falls exactly like we discussed in the positive correlation scatter plot, if it falls exactly on this pink line, then it is said that this x and y are perfectly negatively correlated. Okay, so you will have to add this phrase, perfect negative correlation exists between the two variables x and y. There is one more case. This is the picture that I have showed you when I introduced you to the scatter plot. So from this you can see that the points scatter in the graph, right? So here it is clear that whether you draw a negative slope or a positive slope, the points are not at all around, are not clustered around the positive or the negative line. So it is scattered. So that means that x and y are not at all correlated. They are uncorrelated, and the value of r is equal to 0. Okay. So by viewing the graphs, you must be able to tell that whether two variables are positively correlated, negatively correlated, or if there is no correlation between between the variables x and y. I hope you have all understood the class. Thank you.